Hi everyone, welcome back to Human Anatomy Physiology Lab. This is week 2. I will always put the week in a new color and the exercise. We're going to talk about exercise 28 today. So I'm going to go over 3 main parts of the lab with you. We're going to talk about the human oxygen consumption part of the lab, which is basically what you would have done in class. You and your classmates would have gotten into groups and you would have breathed through a tube and hooked it up to a Vernier machine, and it would have measured your oxygen usage, basically the difference between your oxygen that you were exhaling versus the ambient oxygen in the room. Then I'm going to go over the rat lab portion of the lab because it seems like it's a little bit disconnected. We're talking about human oxygen consumption, and then all of a sudden we're talking about rats and thyroid. And so we're going to be doing these basal metabolic rate calculations. And so basal metabolic rate is a really good way to infer the health of your thyroid, or the activity of your thyroid, because your thyroid is in charge of regulating your metabolism. And so if we can calculate a base metabolic rate, we can draw some conclusions about thyroid production. And then lastly, we're going to talk through the pituitary gland thyroid relationship. That's a big diagram in your book, or no, pardon me, the diagram in your lab report of the thyroid with the little lines next to it. And I will be referencing page 616 in your textbook. First off, just take a look at these lab report instructions. They're pretty useful. It does a really nice job of explaining why we did what we did with measuring people's oxygen, and then it kind of walks you through the steps that you need to do. So the first thing you're gonna do is read through the first page of the lab right here, and then you're given some data. Since you're not generating the data yourself, you'll be given the data, your data from Michael, that will be in red ink, Michael's data. So that's what you're looking for. And then you're going to calculate a percent change. So you're going to be looking at a baseline rate for his metabolism, and then after 3 minutes of exercise, you're going to do another calculation. So after you exercise, you get your muscles acting. You're going to be using more oxygen after you exercise than you would at the baseline. Then the second piece of the lab is all the rat data, and so you're going to be calculating a basal metabolic rate for a bunch of rats, male and female, in 3 different groups. You have 2 variable groups and 1 control group. Then you're going to use all of that data to draw some inferences about the metabolic rates and treatments that your rats were given. So here we are at your lab. Just read through your lab. This is kind of what the procedure was that you would have done in the class. And then you have the 2 values right here. So you have Michael's baseline value here and Michael's exercise value here. And it's these numbers that we're going to take through a set of calculations before we plug it into our final equation. So pay attention to the units here. So for exercise, for example, he's using 7% oxygen in a 15-second increment. So the first thing that we're going to do, we're going to take this value and we're going to be plugging it into this equation following some directions, correct? Yes. Pay special attention to number 19. This information right here in the parentheses. So we're going to take this value and we're going to remember to turn it into a decimal. We're going to multiply by 4,000, and then we're going to plug and chug those numbers into these places. So we're going to have a baseline and an exercise millimeters of oxygen per breath. And so that looks, I'll do one, 5.0, remember 0.05 times 4,000 milliliters equals. And so you'll do that calculation for those two. And then we're going to take these values that you get here and we're going to plug them into this next step, and we're going to multiply by 4 so that we get a per minute rate. Then we're going to take these values that we get right here and we're going to plug them in there, and we're going to multiply these values by 60 because we have 1 minute right here and we need a per hour rate. And so once we get milliliters of O2 per hour, we're ready to put it into our overall equation. And so in number 21, it says, lastly, divide these values by the average US weight. And so you're going to use these weights. You don't have to use your own. So you're going to take this milliliters of O2 per hour. We're going to take these two values. We're going to divide it by one of these weights in kilograms, and then you're going to come up with these values right here. Then we're going to decide, we're going to figure out the percent change between exercise and baseline. And so here is the equation for that. So you'll take your exercise basal metabolic rate and you're going to put it right here, and then you're going to subtract the baseline from it, then you're going to divide by baseline, and then you're going to multiply everything by 100 and you're going to get a percent change. Then you're just going to kind of plug and chug your values for Michael into this chart, and you're going to calculate the percent change for everybody's values. And then answer a few questions about that data. So the next piece of your lab is all about the groups of rats. And so you have 3 groups of rats here. Group A received a chemical that antagonizes T3 and T4, so that means it blocks it somehow. Then you have group B animals that were fed rat chow containing dried thyroid tissue. And then we have our control group right here that are euthyroid or normal thyroid levels and have normal metabolic rates for rats for their size and weight and things. So all you need to be aware of really for this, you're just basically going to be plugging and chugging things into this equation. But note the units. You have to do some things with units right here. We need time in a unit of an hour, and up here we have it in 10 minutes, so you have to convert that. We also need our weight in kilograms, and so up here we have weight in grams, so you're going to have to calculate that before you fill out all of these values. Once you finish the table, you are just going to kind of collate your results right here. I took number 10 and I put it on a slide because they didn't really give you enough space right here to answer this, and so I'm not going to grade question number 10, but I am going to go over it. And so basically what they want you to do, question 10 asks you to correlate these observations with the pretreatments animals received. And so the first, it's just kind of a reiteration of what the groups were. And so remember, group A got a chemical that antagonizes T3 and T4, and so you have to kind of figure out what condition does that mimic. And then group B got the dried thyroid in their food. What condition does that mimic, you know? And then group C was our control group, and they were just normal. And then there is this big diagram right here. I'm just going to kind of go over this diagram on a slide. So here we have the general function of the pituitary gland thyroid feedback loop. And so we start out just with our normal function. Your hypothalamus is going to secrete TRH, so it's going to secrete TRH, and that TRH is going to go down to the anterior pituitary, and the TRH is going to stimulate hormone production in the anterior pituitary. And what's going to happen is the anterior pituitary is then going to create or synthesize thyroid stimulating hormone. The thyroid stimulating hormone is going to go to the thyroid gland, and the thyroid gland, so this goes to the thyroid, and then it's going to make T3 and T4 that goes into the bloodstream. And then once levels in the bloodstream get high, we kind of have to turn off production so that we keep everything in balance. And so we're going to start our negative feedback loop once our blood levels get too high, and that'll be on the next slide. All right, so our negative feedback loop. Our blood levels of T3 and T4 are high. Glucose levels are another indicator or something that can trigger inhibition hormones to be created. And so our blood levels are high. The hypothalamus needs to tell the anterior pituitary, hey, stop making TSH. We have enough. And so now the hypothalamus is going to secrete growth hormone inhibiting hormone, and growth hormone inhibiting hormone is going to make its way to the anterior pituitary, and that is going to, oh man, I can't. Sorry, I keep hitting the wrong buttons. That's going to make, it's going to stop TSH from being made, and stopping TSH from being made is also going to stop T3 and T4 from being synthesized in the thyroid gland. And so once we have T3 and T4 levels brought back down to a normal level, we're going to stimulate the hypothalamus again to secrete TRH, and that's going to go to the anterior pituitary, and it's going to start the whole loop of secreting TSH all over again, and that's the feedback loop. So there's a nice review here in your lab report of kind of the function of TSH, what happens in order. And then you're just gonna answer some questions about thyroid levels and what they mean. And that's about it. So that's your lab for the week. Please email me if you have any questions, and I'll have a new video for you next week. Thanks.